If you've been following the world of AI lately, you know the game has, well, it's fundamentally changed.
It really has.
We are so far past simple chatbots now. We're moving into the age of action.
Right.
We're talking about agentic AI. These are systems that aren't just giving you answers anymore. They are planning, they're acting, and thinking independently to achieve some pretty complex goals. They're basically becoming digital workers. Okay, let's unpack this. If you want to understand the true architecture of this new autonomous digital workforce, you need a blueprint, and you need it fast.
Yeah, you do.
And that is our mission today. We dove into the source materials specifically looking for this new language, the operational lexicon that defines autonomy.
It's building blocks.
Exactly. We
Yeah.
pulled out 10 critical terms that show you exactly how these AI agents operate, how they learn, and how they coordinate. If you're prepping for a meeting or just trying to stay ahead, these are the nuggets you need.
And that approach is exactly what's required right now. The jump from a predictive model, like a large language model, to a truly autonomous agent requires a complete architectural overhaul.
It's a different way of thinking.
It is. You can't just prompt your way to complex multi-step action. So understanding these 10 terms, it really is the shortcut to grasping how these systems are actually built to achieve that independence.
I love that framing. The blueprint for independence. Let's jump right in then.
Okay.
Section 1, the agent's toolkit and its foundations.
Okay.
The first capability that separates, a smart piece of software from an actual agent has to be dynamic tool use.
Precisely. Dynamic tool use is absolutely non-negotiable for autonomy. It's the agent's ability to choose and use external resources on demand.
So things like a web browser or an API or...
Exactly. A web browser for real-time info,
Right.
a proprietary API for inventory checks, a database for internal data, whatever it needs. And it chooses based purely on the task requirement at that moment.
So it's not just having a few fixed integrations baked in at the start.
Not at all.
It's the agent looking at the problem and actually deciding, okay, I need a search engine for this step, but I'm going to need the Stripe API for the next one. And then it just does it.
That's it. It's the ability to reason about the needed resource. If the agent can't figure out which tool is necessary, the whole chain of action just breaks right there.
Right.
That's the key differentiator. It's that flexibility, that choice, that shifts the AI from just being a responder to being a fully capable actor.
But wait, if an agent is pulling in massive amounts of external data using all these tools, how do we make sure its actions are, grounded in reality?
That's a huge concern.
Yeah, I mean, you don't want it just misinterpreting something or worse, hallucinating. It sounds like a recipe for chaos.
And that's where the foundation comes in. Dynamic tool use is completely unreliable without our second term, model context.
Okay, model context.
Model context is the grounding mechanism. It's the set of processes that ensure the model's output is based on verifiable, external, current data, not just its old static training set.
So it's a filter, basically.
It's a filter, yeah. The agent uses a tool, gets an output, and then it pulls only the absolutely relevant context back into its working memory before it decides what to do next.
So it ensures the action is based on reality.
Exactly. It makes the whole process robust and, frankly, trustworthy.
That makes perfect sense. It's like hearing a rumor versus actually verifying the source before you act.
Mm-hmm. A perfect analogy.
So the agent can act, and it can act accurately. Now, the next logical question is, how do we scale that? How do we coordinate multiple agents? That brings us to communication, starting with the simplest form, A2A.
Agent-to-agent communication.
Right, yeah, A2A.
And A2A is really that foundational layer of collaboration. It's defined simply as two agents automatically exchanging messages and data.
And the big benefit, I assume, is getting the human out of the loop.
That's the one. When one agent finishes a task, it doesn't need a person to copy and paste the result to the next agent. It's just an instantaneous machine-to-machine exchange.
Huge efficiency leap for basic workflows. But communication needs standards if you want complexity. It needs a common language, a protocol.
You're right. And that standardization is handled by our fourth term, MCP.
MCP,
And we should spell this one out because it's critical. It stands for Modular Component Protocol.
a modular component protocol. Okay.
It's the engineering layer that supports A2A. It standardizes how agents connect not just to each other, but critically, how they connect to tools, to context, to memory. All of it.
So it's more about the plumbing than the conversation.
That's a great way to put it. What's fascinating here is that MCP makes everything more modular. Developers can easily swap one tool for another or reuse a memory module across completely different agent systems. It keeps these things from becoming these bespoke, unmaintainable silos.
So if dynamic tool use is the ability to choose a wrench
Mm-hmm.
and model context make sure you're tightening the right bolt,
Yeah.
then MCP is the standardized rack that holds all your tools and ensures every agent knows exactly how to pick up and put back that wrench.
Perfect. That's a truly scalable foundation right there.
Okay, let's transition. Let's talk about persistence and workflow. The agent's ability to remember things and manage complex multi-stage projects. This has to start with long-term memory.
It absolutely is the key.
I think for a lot of people, this is the thing that moves AI beyond just a single chat session.
100%. Unlike earlier models that were basically limited to their prompt window, where memory just flushed after every single interaction, long-term memory lets agents retain information across totally different tasks and sessions,
For how long, potentially?
potentially months or even years.
Wow. But how does that technically work? How does it keep that institutional knowledge without just, relying on a giant, slow database query every time?
That's a great question because it's not just a database. These systems often use things like vector databases and RAG techniques, retrieval augmented generation.
So it's more complex.
Much more. The agent takes its experiences, the results, the outcomes, the failures, and converts them into these dense numerical vectors. When a new task comes in, it queries those vectors not just for keywords, but for semantic similarity.
So it's looking for concepts, not just words.
Exactly. It lets the agent recall what worked before, stay consistent, and apply past lessons to new, seemingly unrelated tasks. It's much, much more efficient than just reading a log file.
So it's not rote memorization, it's actual applicable experience.
That's it.
Okay, so now an agent can remember. It has complex knowledge. It needs a way to use that knowledge to run a multi-step project without a human watching over its shoulder. That takes us to workflow orchestration.
Right. Once an agent remembers things, you need a method to coordinate its actions into a cohesive path. And workflow orchestration is exactly that coordination mechanism.
So it's chaining tasks together.
Systematically. It's about chaining tasks across different tools, memory retrieval steps, or even across multiple agents in a very specific conditional sequence.
That orchestration sounds incredibly complex. What's the biggest, failure point when you're trying to chain steps like that?
That's a great question. The main failure point is almost always state management.
State management.
Yeah, just knowing exactly where you are in the process and making sure the context is maintained perfectly across all the different branches and conditions, it's hard.
So how do you solve that?
This is why the source material points to specific systems like LangGraph or LangFlow. They aren't just names, they are tools designed to manage the state of the workflow. They let developers define the whole process as a state machine.
Ah, okay.
And that structure ensures the agent follows the logical path even when it hits an error, and it knows exactly how to recover or pivot. It's like the conductor for the orchestra.
So we're moving from writing 10 separate scripts to just giving one instruction and watching the whole thing happen with error handling and memory all built in. That's a massive shift.
It's a huge shift in scale, yes.
All right, now let's dive into the internal mechanics. Decision-making, advanced teamwork, we get the workflow. But how does an agent decide which path is best when it has multiple choices? That requires some internal measure of success, which is our next term, the utility function.
The utility function. This is the core engine of optimization for the agent. In simple terms, it's the formula it uses to score the potential outcomes of its available actions.
So it's an internal grading system.
It's more than that. For a technical listener, you should think of it as the mathematical definition of the agent's objective.
Okay.
Because agents are often tasked with complex problems, minimizing costs, maximizing speed, some blend of both. That objective has to be quantifiable. The utility function translates that high-level goal into a numerical target. It's the agent's internal compass, constantly driving it toward the defined optimum.
That internal scoring becomes absolutely crucial when we introduce true collaboration. We talked about A2A earlier, simple message passing.
Right.
But if agents are working together on a high-stakes goal, defined by that utility function, they need something much more robust.
Absolutely. And that's why the eighth term is inter-agent communication.
Inter-agent communication. How is that different from A2A?
It goes way beyond the basic message exchange of A2A. Inter-agent communication involves using structured, formal protocols for coordination.
What does a structured protocol actually mean in this context?
It means communication is built around specific roles and intentions. So instead of Agent A just saying, here's the data, it might use a protocol for, say, negotiation.
Like it.
I need resource X for 3 minutes, are you available? Or a protocol for resource locking to make sure two agents don't try to edit the same file at the same time and create a conflict.
Oh, I see.
These structured protocols enable really sophisticated collaboration, knowledge sharing, and, most importantly, safe coordination.
It's the difference between two people shouting across a room versus sitting down with a formal agenda to resolve a conflict.
Exactly. It introduces order into complexity.
So now you have structured collaboration driven by a mathematical scoring mechanism. Okay, finally, let's get to improvement and safety. I think these are the most human-like parts. Term number 9 is reflection.
Reflection. This is the agent's mechanism for conscious self-improvement. It's the process where, after completing a task, or more critically, after failing a task, the agent systematically looks back at its own process.
So it's not just acting, it's consciously learning from its failures. It's very human. But how does that actually manifest in the architecture? Is it just logging an error?
No, it's a dedicated process. It often involves a secondary, higher-level prompt that runs after the fact. The agent reviews the trace logs of its actions, it identifies where its utility function score dropped or where the process broke, and then it generates a self-critique.
It critiques itself.
Yeah, it asks itself, what could I have done differently? And that critique feeds directly back into its long-term memory and influences its planning for the next time. It's basically self-prompting for error analysis.
That is fascinating. An AI that strategically self-corrects. And that self-correction is completely dependent on knowing exactly what went wrong.
Which requires constant measurement.
Right.
And that is the final crucial piece of the blueprint, linking reflection to real-world safety. Observability tools.
Observability tools.
The role of these tools is to ensure everything is measurable and accountable. When these complex agents are running live in production, these tools are mandatory. They monitor every function call, they track performance, latency, failure rates. They log the entire decision path.
So without that logging infrastructure.
Reflection is impossible.
And for you, the listener, this is why these tools are so essential. They provide the trust layer. You, the developer, you can't learn from mistakes or debug errors if you can't fully trace the agent's internal life. These are the guardrails.
The essential guardrails that let us deploy these things confidently out in the wild.
We have covered a lot of ground here. We traced the architecture all the way from grabbing a tool dynamically all the way through to the structural elements like the modular component protocol.
Yeah.
So what does this all mean when you put these 10 terms together?
It means AI is fundamentally evolving its own complex, reliable operating system.
An operating system.
Yeah. If you take away anything from this deep dive, understand that these 10 terms are the blueprint for truly autonomous digital workers. The ability for agents to chain complex steps through workflow orchestration while retaining past successes and failures via long-term memory, that is the step change you need to be aware of.
That's the key takeaway.
This is the definition of AI moving beyond simple instruction following and into genuine adaptive problem solving.
Okay.
And here's a final provocative thought for you to consider, building on the utility function and reflection. If an agent is constantly learning from its mistakes, that's reflection, and at the same time it's always seeking the highest possible score from its utility function. How might those two systems conflict? Or maybe, how might they align when the agent is optimizing for a long-term goal that's unpredictable or maybe even ethically ambiguous?
Yeah.
That tension between objective scoring and strategic self-critique, that is absolutely going to define the next generation of how we manage and oversee these agents.